Okay, guys, over the Thanksgiving break, we asked you to look at some algebra atrocities. And the first atrocity that we are asking you to make a conscious effort not to make is simplifying rational expressions by canceling out terms. You don't want to cancel out terms. So, what is a term? Well, to explain this, we're going to show you a basic example, 3 over 6. And all of you know that 3 over 6 equals 1/2, but is it really known as to why? I think you know that you can take out a common factor that 3 and 6 both share, but I want to show you this in uh, a different way. 3 is equivalent to 1 times 3, and 6 is equivalent to 2 times 3, and now I have the numerator 3 written as a pair of factors 1 times 3, and I also have 6 written as a pair of factors 2 times 3. And I want to note that multiplication is in between these two things, which means they are factors of the original number, so therefore we can cancel out any common factors that we might see, hence the 3's being able to cancel. The key here is this multiplication in between. Okay? So, as we already knew, 3 over 6 equals 1/2 because of being able to cancel out a common factor. So when I come down here to my more difficult example here with letters, algebraic example here, I guess you'd say, I want to look at, first of all, factoring the numerator and the denominator. So 15, I guess I could write it as a product of two factors if I wanted to, but I think you guys are decent with your number sense that you know that the factors of 15 are 5 and 3, or 1 in itself. In the numerator, I have a binomial, and it's separated by addition. So what a common mistake would be, kids want to just cancel out a common factor with the 5 and the 15 here, and that's not allowed because of this addition being the separator here, the term separator. And remember, we want it to be multiplication in between, like our basic example here with 3 over 6. So what we can do is we can take the denominator and factor it, and the only factoring method for this binomial is a GCF. So the common factor between 5x and 10 is a 5, and that would leave me with x plus 2 still on the inside, and then I still have my 15 in the numerator. Now at this point there is multiplication in between here. There is multiplication in between the 5 and the new binomial x plus 2. It's 5 times this quantity. So I can now say that I would be able to cancel out any common factor that I might have with the numerator, meaning I can take out a common factor of 5 here, making this a 3 and this a 1, and rewrite my final simplified version of this as 3 over x plus 2. Okay? Again, the key being that we need multiplication in between, like we did up here. So we look at the numerator and the denominator and consider factoring it. In another example, we have a trinomial in the numerator and a trinomial in the denominator, and the common misconception would be to just cancel out common factors here and cancel out common factors here with the 18 and the 15. However, we look at the separator here. These are terms. They're separated by addition or subtraction, so they're not actually available for cancellation. So our first job is to factor both parts, the numerator and the denominator, and this is a pretty simple factoring question. Factors of 18, negative 18 that add up to negative 3 would be a negative 6 and a positive 3. And then in the denominator, I can also find factors of the negative 15 that add up to negative 2, giving me x, it'll be minus 5 and a plus 3. And now, noting that there is multiplication in between these two, we have two binomial factors in the numerator. We have an x minus 6 and an x plus 3. And we have two binomial factors in the denominator. And since they're separated by multiplication, if we have any like factors, they're available to be canceled out, because anything divided by itself equals 1 right there. So these will cancel. So our final answer in this question would be x minus 5, or x minus 6, excuse me, over x minus 5. And again, another misconception here at this point would be to try and cancel out additional factors here with these x's. But as we look, these are separated by subtraction, and likewise down here, so they are not separated by multiplication, therefore these are not factors, and being independent enough to cancel out any like factors. So this is our final answer. So again, to avoid the algebra atrocity of canceling out terms, make sure you factor first.